Hello students, welcome to the next video on Analog Electronics 1. Myself Gunjan Mittal Roy in the Department of Electronics and Communication Engineering in Jamtech, Greater Noida. So the next topic of my video of today is classification of negative feedback amplifiers. In the previous video we have covered different what is the feedback concept, how do we apply it, what are the advantages of feedback, how many types of feedbacks are there. Mainly there are positive feedback and negative feedback, and now since we know that the negative feedback has got a lot many advantages over positive feedback, so it is widely used in amplifiers. Now there are a category or classification of negative feedback amplifiers. So they are broadly classified into categories, which are negative voltage feedback and negative current feedback. In case of negative voltage feedback, the voltage feedback to the input of an amplifier is proportional to the output voltage. This is further classified into two types, now voltage series feedback and voltage shunt feedback. The negative current feedback is again there the output in this the voltage feedback to the input of amplifier is proportional to the output current, and it is also classified into categories, which are current series feedback and current shunt. So overall we have four types of negative feedback systems, which are voltage series, voltage shunt, current series and current shunt. All of them we will discuss one by one. So first is voltage series feedback. In a voltage series feedback, a fraction of the output voltage is applied in series with the input voltage through the feedback circuit. Here the voltage series feedback means the output energy which is fed back to the system is voltage, and the input port is in series, and in series we know the voltages are being added up, so the input energy is also voltage, and the output voltage is fed to the negative feedback system or negative feedback block. Okay, now the voltage is applied to the feedback system or feedback network, and the voltage is same in shunt, so the output port is in shunt and the input port is in series. So this is the voltage series feedback. As the feedback circuit is connected in shunt with the output impedance is decreased, and due to the series connection at the input impedance is increased. So this is the main first advantage comes out in this configuration, that as I told you that the output connection is in shunt and the input connection is in series, and in shunt the output impedance decreases and in series the input impedance increases. Therefore we get the advantage of improved impedance by having high input impedance and low output impedance. So this is the very first configuration, which is voltage series configuration, and I told you the output energy is voltage, which is fed back to the feedback circuit in shunt, and the name series comes because the input port has the voltages added up in series. Okay, there are two main blocks, which are amplifier block and feedback circuit. The input to the amplifier is Vi and output of the amplifier is V0 taken across the load RL. The feedback network has the feedback factor of beta, and the output of the feedback circuit is Vf, which is equal to beta times V0, and it is in the negative feedback mode, so this is given as minus beta V0, and the overall input voltage source is given by Vs. In the voltage shunt feedback circuit, fraction of the output voltage is applied in parallel with the input voltage through the feedback network. This is also known as the shunt driven shunt fed feedback, that is a parallel prototype system. And the circuit block diagram shows it is evident that the feedback circuit is placed in shunt with the output and also with the input. As the feedback circuit is connected in shunt with the output and the input as well, both output impedance and the input impedance are decreased. So this is the case of voltage shunt. So in case of voltage series, the output voltage energy applied is voltage and the input port is in series. In case of voltage shunt configuration, the output energy is voltage but the input port is in shunt, and in shunt the current gets divided. So the input energy is current and the output energy is voltage. So it is also a kind of trans-impedance amplifier where it has the ratio of V out upon I in. So it is a trans-impedance amplifier, and the output is in shunt and input is also in shunt. So the output impedance decreases as well as the input impedance also decreases. So here we get one advantageous parameter and one disadvantageous parameter. That the output impedance decreases is good, but the input impedance should be high and this is also decreasing. So this is a drawback of this particular network. This is the configuration that the output voltage is in shunt, which is going to the feedback circuit, and input voltage is also in shunt, and in the shunt the parameters get divided, the current gets divided. So most of the time it is a input energy is current and it is a trans impedance amplifier. Next comes is the current series feedback. In case of a current series feedback, the output port is the output energy rather applied is current, and since the current flows in series, the same value of the current gets in series, so the output port is in series, and input port is also in series as the name is suggesting, series feedback. So here at the input there is voltage applied in series and the output there is current which is coming in the series. So it is the output current upon input voltage. It is a kind of a trans conductance amplifier, and since the output port is in series, so the output impedance increases, and the input port is also in series, so the input impedance increases. So both impedances increase in this case, and therefore there is one advantage and one disadvantage. The input impedance increment is the advantage and the output impedance increment is the disadvantage. And this is the basic configuration of this particular type of amplifier, which is a current series amplifier. The next and the last is the current shunt feedback, and here the output energy is the current which comes in series and the input port is in shunt, and in shunt since the currents get divided, so mostly there is a current source at the input port and output current is coming to the feedback network. So the energy at the output is also current and at the input it is also current, so there is a ratio of I out and I in, and since the input and output both are in output is in series and input is in shunt, so due to this fact the input impedance is decreased and output impedance is increased. So it is just means both the parameters are not at all of any use, and there is both drawbacks. And the input impedance should be high, so it is decreasing, and the output impedance should be low and it is increasing. So in case of fourth configuration, which is the current shunt feedback, both impedance parameters are poor. And this is the circuit configuration. With this, I would like to conclude this topic of typical characteristics or classifications of feedback amplifiers. Thank you so much.